Good afternoon, everyone, and welcome to the Firestop Contractors International Association's Firestopping Education for ASHI members on March 31, 2016. We appreciate the opportunity to be part of the resource pages at the American Society for Healthcare Engineering, and always enjoy working with the ASHI members wherever we go across the country. My name is Bill McHugh. I'm the Executive Director of the Firestop Contractors International Association based in Hillside, Illinois, just outside Chicago. My contact information is on the screen. For further resources and to catch the schedules for our barrier symposiums, full-day programs put on by ASHI regions featuring the American Society for Healthcare Engineering, the Joint Commission, Underwriters Laboratories, and the Firestop Contractors International Association. Together, we produce the Barrier Management Symposiums, which cover everything from tested and listed systems from Underwriters Laboratories for fire resistance, barriers from Koffel Associates, the barriers themselves made of gypsum, and fire stopping, fire dampers, fire-rated glazing, as well as barrier management. A great program. Visit FCIA.org for more information, along with ASHI.org to keep an eye out for those programs. Today's program is focused at fire stopping. We're going to focus on compartmentation and fire resistance. We're going to recognize the various tested and listed systems for penetration fire stopping, joints, perimeter fire containment. What are the designs and tested systems? How are they installed? And what are the requirements, qualifications for those that install fire stopping? What are the inspection requirements in new construction? And then finally, how do we manage the barriers once they've been installed and the building becomes a living and breathing thing? We're going to understand these requirements for safety in both U.S. and Canadian operations. And we'll cover a little bit about specifications, which will set up a building that you can maintain after it's been constructed. When looking at management, the best thing to do is look at the inputs. The input in new construction is the specification. The specification is what sets up the building that's going to be delivered to you at the end of the day. The Firestop Contractors International Association is a worldwide organization with members from India, the Middle East, South and Central America, the U.S. and Canada. We have members that are Firestop contractors, manufacturers, consultants, manufacturers, reps, and distributors. We publish a magazine, Life Safety Digest, the magazine of effective compartmentation. Our website is open and free with all kinds of resources, including full copies of the Barrier Management Symposium presentations at FCIA.org. We offer our Manual of Practice, the Firestop Industry Manual of Practice, to architects, specifiers, governmental officials, building and fire officials worldwide, free of charge as a service from the industry. Today's program is about fire stopping. It's also about the DIIM, the proper design, installation, inspection, maintenance, and management of fire stopping. Properly designed fire stopping is specified properly by a registered specification writer in Canada. In the U.S., a certified construction specifier, construction document technologist. In specifications will be found in Division 7. There is a section specifically for fire stopping called 078400. That's where fire stopping should be specified all in one place. Joints, penetrations, perimeter fire containment, all should be specified in this one section to avoid confusion and to make sure that the requirements for this one discipline, fire stopping, are consistent regardless of what type of breach was created in a fire resistance rated wall or floor or both. Secondly, in the design, tested and listed systems are imperative. The manufacturers of fire stopping have invested millions of dollars at various testing laboratories, including UL, Intertech, and FM approvals, testing their products to standards to determine the suitability for use of the products in specific applications as fire resistance rated systems, as well as smoke resistant systems as well. Whether it's ASTM E814 and UL 1479 for taking care of the breaches created to allow penetrating items such as pipes, cables, ducts, and other things to go through fire resistance rated construction, or to create a membrane penetration where the breach occurs only in one side of the wall, allowing that penetrating item to go into the wall and then dive down, go up, or sideways to service another part of the building. ASTM E1966 and UL 2079 cover wall-to-wall joints, floor-to-floor joints, and floor-to-wall joints, while ASTM E2837 covers the head of wall joint when the top assembly is not fire resistance rated. The UL 2079 and ASTM E1966 are also used for head of wall assemblies. However, that's where there's a fire resistance rated construction for both the ceiling above or roof above as well as the wall assembly. Finally, the ASTM E2307 is the test standard for perimeter fire containment systems. ULC S115, the Canadian standard, covers ASTM or UL 1479 and UL 2079. We'll get into the details of what the results are of these tested and listed systems later in the program. For installation, FCIA member FM 4991 approved UL qualified contractors provide systems that were installed to tested and listed systems. The fire don't get ratings. The systems do. We'll cover that in detail later as well. Inspection is also important in new construction. Before that building is turned over to you, an inspection to ASTM E2174 and ASTM E2393 by IAS International Accreditation Services accredited inspection agencies to IAS's AC291. Both the UL and FM 4991 programs, along with the IAS AC291 programs, bring a quality management system process to both of these companies. Just like your organization is audited by the Joint Commission, these contractors and inspection agencies that subject themselves to FM approval or UL qualification, or the inspection agencies that subject themselves to IAS accreditation, they are audited as well. Their management systems are audited by those third-party independent organizations to be sure they do as they say they do all day long. Maintenance and management is also important. We'll cover that towards the end of the program. First, FCIA believes in total fire protection. We believe that the systems that are in buildings, and those systems include effective compartmentation, including the fire barriers, smoke barriers, fire partitions, smoke partitions, fire walls, fire resistance rated horizontal assemblies, all protected with the features of fire resistance, meaning fire stopping, fire doors, both rolling and swinging doors, fire dampers, and fire-rated glazing, provide the six-sided box that keeps fire and smoke from spreading to other parts of the building. This is the concept that allows for horizontal evacuation of buildings rather than moving people up and down out of a healthcare facility that might not be able to move as quickly as those in office buildings or other occupancies. Secondly, detection alarm systems are quite important. Without notification that there's a issue by an alarm, we really don't know that there's an emergency in the building and we have to move. Sprinkler systems are important as well. And most importantly, and healthcare occupancies do this best, education of staff as well as the occupants about the egress methods that are used to get out of the building. Building owners and managers, building occupants and firefighters all work together to make sure that people get out of buildings safely. So on to our program. The DIIM, the proper design, installation, inspection, maintenance and management of fire stopping, in addition to the rest of the fire barrier, the door, the damper, making sure that the fire-rated glazing is in place in the right way, and the wall or floor itself, making sure that its continuity is there, is imperative to fire resistance rated construction working. The building and fire codes have requirements for fire resistance rated construction. In NFPA 5000 and NFPA 101, fire resistance is found in Chapter 8. In the international codes, fire resistance is found in Chapter 7 of both the International Building Code and the International Fire Code. These codes set up the minimum requirements for both construction and maintenance. In the codes, fire resistance has a definition. It's basically the time in minutes or hours that the materials or assemblies have withstood a fire exposure as determined by three things. The first is determined by tests. I put tests up earlier. ASTM E814 and UL 1479 is the test method for penetrations. There are other test methods to test the wall itself. ASTM E119, UL 263 would be the test standards used to determine the fire resistance rating of the wall itself. Methods based on tests and calculated fire resistance is found in Section 722 of the International Building Code. That would be the second method, methods based on tests. Thirdly, this code is mentioned as a way to determine fire resistance. In Section 721 of the International Building Code, there's a section that deals with archaic assemblies, clay tile block, gypsum block, and all the other interesting construction materials that were used many, many years ago are still cataloged in one place, and you can find their fire resistance through looking through Chapter 7 of the International Building Code. In the international codes, fire resistance has one more thing added to it, and it says that the systems are what is used to provide that fire resistance. When you think about fire resistance, all of it is a system. The fire resistance rating of the wall is tested at UL to ASTM E119 and UL 263. The result is published in the UL Fire Resistance Directory, available online at ul.com under the Certifications Directory or through other directories, FM Approvals at FM, their website, approvalguide.com, or at Intertex directory as well. So each of these products are assembled to the recipe in those tested and listed systems to provide fire resistance rated construction. Without the materials being installed to those designs, we have no idea what the fire performance will be of those assemblies. So the number one takeaway from this program is that you have to ask for the systems. When someone says to you, I just put up a fire rated wall, you say, okay, what kind of fire rated wall? And then secondly, what system did you use to make that a fire resistance rated wall? In common, regardless of the code, is this thing called continuity. Continuity of fire resistance rated construction and smoke resistant properties of the products that are used, all done with a system, is where the continuous fire resistance comes from. The breaches that are made for penetrations and for openings, such as joints that allow for movement of two independent structures, have to have continuity of their fire resistance through those breaches. Fire stopping provides some of that. The other features of fire resistance also provide it. Terminology is very important, definitions and terminology. Why? Because each of these items that are listed on the screen, fire barriers, fire walls, fire partitions, smoke barriers, and smoke partitions, are different items. For instance, a fire barrier won't bring protection enough to be used alone in a smoke barrier. A smoke barrier asks for continuity and smoke resistance. The fire barrier only asks for fire resistance. So they're not all equal. The fire barrier is an hourly rated assembly, continuous from outside wall to outside wall, from fire resistance rated assembly below to fire resistance rated assembly above. The fire wall is different. The fire wall would be extending from the foundation, basement if you will, or whatever level that lowest level of structure is, through the roof assembly and through every floor, and also have structural independence such that one side of the fire wall could completely collapse by fire, and then on the other side, where fire hopefully did not penetrate through, it would remain standing. So structural independence is in firewalls. It's not in fire barriers. Fire barriers are only continuous from barrier to barrier. In other words, from horizontal assembly to horizontal assembly, and does not have that structural independence. High challenge firewalls are something you'll find in industrial type facilities or where there's high risk and hazards. Fire partitions are fire resistance rated assemblies, but might not be continuous. Fire barriers are used for lots of things. Fire area separations, hazardous area separations, shaft enclosures, horizontal exits, and corridor walls. Smoke barriers are something that are unique to healthcare occupancies. Smoke barriers have one different thing that doesn't occur in the fire barrier. The International Building Code, under the smoke barrier section, it calls for a quantified air leakage rating for fire stops. In NFPA 101, it does not currently call for a quantified air leakage rating. A smoke barrier is defined by the International Building Code as a minimum 1-hour fire resistance rated assembly with the continuity clause and having an L rating. In the International Building Code, starting in 2006, there were numbers required for the minimum amount of air leakage that could go through the assembly in cubic feet per minute per square foot of opening area. The current requirements in the 2009 code going forward into the 2012 and 2015 code, as well as the 2018 code, says that each individual penetration can have less than 5 cubic feet per minute per square foot of opening area for each penetration, or 100 square foot of wall area can have less than 50 cubic feet per minute per 100 square feet of wall area. So that would mean that either or, if there is a single penetrating item and its L rating, air leakage rating, is greater than 5, then they would not be complying with the International Building Code. However, the second option for the building owner is, let's take a 10 by 10 area, then add up the penetrating items as they go through that wall and figure out whether or not we have greater than 50 cubic feet per minute per 100 square foot of wall area. It's not hard to do. It just takes diligence and understanding that the fire resistance rated construction that has smoke resistant properties called for and an L rating has to be monitored. Specialty fire stop contractors understand this, and it's something you should understand when you're asking those people who are installing fire stops if they understand what they're doing as they go through a smoke barrier or as they treat the breach through that smoke barrier where a penetrating item was moving through it. The NFPA 101 does not have a quantified air leakage rating required. It simply says restrict the passage of smoke. However, it still asks for a continuous barrier, and that continuity be from barrier to barrier through concealed spaces. The fire resistance rating of that smoke barrier are critical in addition to the smoke resistant properties. Should an air leakage rated fire stop be used for smoke barriers regardless of code? In FCIA's opinion, yes. Why? Because the due diligence required by not just the patients, because we are after patient safety in structures, and we're after occupant structures. But the due diligence is that whenever something says it should resist smoke, there is a standard that would be researched if there were ever a disaster, if you will. And once that standard is found, then the care needed to make sure that smoke resistance was covered would be that standard. That's what the legal profession would look for. And they'd ask questions of the contractor, the building owner and manager, general contractor, and others. Mr. or Mrs. Contractor, why did you not use an L-rated fire stop in that smoke barrier? Well, the code only said restrict the passage of smoke, didn't ask for a quantified L rating. Isn't the L rating the suitability for use statement of products in specific applications when it comes to smoke for fire stopping? Yes, it is. Well, why didn't you choose the lowest possible system for that when it was available? Well, we just didn't think we needed it. You can see where the jury and judges would go without paying attention when contractors and others don't pay attention to the air leakage rating, regardless of whether it's a smoke barrier or a smoke partition that is used. The smoke partition is a continuous barrier but doesn't have a fire resistance rating. Fire stop products have air leakage ratings. They would have both a 1 hour or a 2 hour or more fire resistance rating, and then have the L rating with them. There are no products that are tested as systems with an L rating alone. They come with both the fire and the smoke, and they're individual systems. The products themselves don't get the ratings, the systems do. So let's say there was a metal pipe going through a breach in a fire resistance rated wall that's a smoke barrier. It's a minimum 1 hour fire resistance rated assembly and needs to have an L rating. What would we choose? A fire stop system that has fire stop products that are able to provide an air leakage rating as good as we can get it. The lowest we can get is less than 1 cubic feet per minute per square foot of opening area. Enough about smoke barriers and smoke partitions. Just remember that L ratings, air leakage ratings, are the suitability for use statement for when somebody says, I'm going to smoke seal something, whether it's a penetration through a breach that goes through a wall or floor, or a breach created to make a gap where two assemblies can move independent of each other, also known as a joint fire stop system. Where else are fire resistance rated assemblies used? They're used in exterior walls when buildings are located too close to each other. They're used as firewalls, fire barriers, fire partitions, and then again, smoke barriers and smoke partitions. The continuous fire resistance is across all different codes. All codes require continuous fire resistance. Any of the products don't become fire stop systems until they're installed in the breaches to that tested and listed system. Fire stop penetrations and joints have tested and listed systems. So do fire and smoke dampers. Fire and smoke dampers are tested to UL 555 and UL 555S. The result is a tested and listed system that's published in the manufacturer's installation instructions when you buy one of these dampers. Fire doors and hardware also are tested and listed systems to UL 10B, 10C, and provide fire resistance continuity through a large breach in a fire resistance rated assembly. The rolling door would be the largest hole in that fire rated assembly. Swinging doors, along with their builder's hardware and closers, also need to be fire resistance rated. Then finally, fire resistance rated glazing tested to ASTM E119, and UL 263 goes through the same testing that fire stopping goes through, dampers go through, fire doors and hardware go through, and fire rated glazing. That same testing, temperature curve of 0 to 1,000 degrees in about 5 minutes, out to almost 2,000 degrees within a couple of hours. Thermocouples placed on the cold side of the assembly to see how much time it takes for the cold side of the assembly to heat up 325 degrees over its starting temperature. And then finally, a hose stream test. We'll go over that here shortly. The next question you might ask is, okay, great, we've covered fire resistance and smoke resistance. What kind of standards are there for other things that might be of concern to healthcare professionals? What about chemical, biological, and radiation resistance, as well as explosion resistance? Where's radiation? Radiation's in X-ray rooms. Firestop systems were built from the nuclear power industry. That's where they got their start. Many of the products do have radiation resistance. You just have to ask for it in your construction document specifications so that the contractors provide it. What about blast resistance? If your facility is a high-rise facility, and there are many of them around the country, higher than 420 feet above lowest fire department access, then explosion resistance is required for stairwells as well as critical shafts in the building. What about the fire stop? What about the door? What about the wall? Does it have the blast strength to protect against things that might happen in super high-rise buildings? That code proposal was a result of the World Trade Center disasters in 2001. The Ad Hoc Committee on Terrorism-Resistant Buildings at the International Code Council, through its code development process, came up with those numbers. Look for it in the high-rise section of the International Building Code. What about chemical, biological, and germ resistance? They're not published on Firestop systems designs. Those are physical properties that you have to ask the manufacturer, their industrial hygienist, put them together with your industrial hygienist at your facility, and make sure that the products have resistance to the chemicals, the biological agents, or the germs that might be moving around in your facility. It might mean a change in physical properties. It might mean a different product is used in addition to the Firestop system designs that are used in the building. Regardless, there's some extra due diligence to do for healthcare facilities that might not be done in other occupancies. Effective compartmentation is something that's important for all occupancies. Certainly healthcare is important, and that's what we're talking about. But throughout other occupancies, effective compartmentation and fire resistance is used to protect buildings. In high-rise construction, for instance, the statistics show that effective compartmentation provides total fire protection along with sprinklers, alarms, and egress. Out of the high-rise buildings in North America, there's about 11,000 of them, 20 stories and higher. 70% of them are in cities where there are older construction. New York, San Francisco, Chicago have a lot of buildings dating back to the mid-1800s and early 1900s. Fire resistance is the main line of defense, and was for the existing buildings when they were first built. Sprinklers and alarms were added later. Therefore, those buildings are safe because they've got all types of fire protection in them, along with egress systems and occupant education. In San Francisco, Los Angeles, and Hawaii, earthquakes take place. High fire resistance ratings, along with sprinklers and alarms. Therefore, we believe buildings are safe because they have all those things in them, and not just because a sprinkler system is there. The staff that exist in healthcare facilities makes those buildings even safer, knowing what the emergency procedures are. So fire resistance rated walls and floors are important, and they're built from many materials. Whether it's concrete block, plaster, gypsum block, clay tile block, gypsum board, also known as drywall, or a combination floor ceiling assembly of some kind. Continuity of fire resistance is provided through these tested and listed wall and floor systems. Those systems have testing, or they've been determined to be fire resistance rated by methods based on tests or calculations, or this code, Chapter 721 of the International Building Code. Whether it's a fire damper, a fire door, glazing, the wall itself, or the fire stop, continuity is critical to making fire resistance work. Taking a look at this fire resistance rated wall on the left-hand side, you can notice that there's a few things that are common to all fire resistance rated wallboard assemblies. First thing is the joints are taped. The joints are taped continuously from top of the wall to the bottom of the wall. Secondly, fasteners have a wallboard compound covering them as well. Secondly, on the other side of this wall, the joints would be offset such that they don't occur right on top of each other. The only way that they could occur on top of each other is if the tested and listed system from UL or another fire resistance directory had allowed that kind of system to exist. So number one question is, what system is used in order to make this work? Also notice that the pattern for fastening of the wall assembly is very uniform, such that the fasteners are in place in their right spot as listed in the tested and listed system. That's the design. DIIM started the design. Tested and listed systems is what makes this industry work. Firestop professionals obviously know a few things. First one is safety equipment. Ready with the hard hat? A slight violation in that it's on backwards. He'd straighten it out when he gets up on the ladder. But they also know how to get around a building, understand the life safety drawings that would have fire resistance rated construction marked on them. Finally, he or she is working with the tested and listed systems for each penetration, joint, fire containment system, and understanding what they are and the types of products that are used to get them installed properly. Secondly, the manufacturer's installation instructions are required in order to get fire stopping installed to the tested and listed system. These three things are critical to installing fire stopping. If you've noticed, I've not shown one bit of fire stop material in this picture. Why? Because 90% of the action of fire stopping is understanding the tested and listed systems and their limitations. The other 10% is installing the fire stop sealant, wrap strip, pillow, or other product to that tested and listed system. The system selection and analysis is what's needed in order to be a professional fire stop, either installer or inspector working for an inspection agency, installer working for a contractor, or working for your staff. So the tested and listed systems are what's needed. The objective of fire stopping is matching the tested and listed systems on the left to the penetrating items that are going through the breaches in those fire resistance rated assemblies, whether they're singular or multiple metal pipes, single or multiple cables, blank openings, in sleeves or not in sleeves. A fire stop system exists, or an engineering judgment, in order to provide the fire resistance rated construction to what it was before somebody poked a hole, breached the continuity of that fire resistance with that penetrating item. Fire stop products become systems when they're installed. Take a look at this definition from the UL directory. Fire stopping is an action. It's a specific field-directed construction consisting of an assemblage of materials to prevent the spread of fire through openings in fire-rated walls and floors, using the test methods I've got up in front of you. The testing is the suitability for use statement of the fire stop product in a specific application. So the mere fact that there is red sealant around these penetrating items in the picture below doesn't mean that that fire stop has been installed properly. It's not been installed properly until it's been installed to the tested and listed system, and we'll bring up what those are here shortly. There are many fire stop products that are available in the industry today. The fire stop sealants are probably the workhorse of the fire stop industry. A large percentage of fire stopping can be done using sealants alone. There are many different types: silicones, latex, silicone intumescent, and latex intumescent. The intumescent word is a very simple word. What intumescing means is that it expands when exposed to heat. Think of a snake on the 4th of July that you might light with a match, and it expands and moves around, making a soft, fluffy char. The intumescent used in fire stopping does that same expansion, only not quite as fast, and when it expands, it makes a char, an insulating char, hard enough to provide fire resistance for a period of time. It's an insulating action that, while fire is occurring on one side, is not transferring heat to the other side. There are also other types of fire stop sealants, endothermics and ceramic fibers. Wrap strips are available in many different types, thick, thin, wide, or less wide, used around plastic insulated penetrating items, sometimes cable trays, sometimes bus ducts, to expand at the rate that something is warping or melting in a fire. Large plastic pipes, for instance, make big holes when they burn and melt away after about 7 minutes in a fire. The intumescent action of both sealants and wrap strips crushes the penetrating item and fills the void made as it's melting, therefore insulating the assembly and providing fire resistance. Then there are putties, pillows, composite sheets, Firestop bricks made of foam with all kinds of graphite laden inside those foam bricks, and then prefabricated kits, Firestop mortars, as you see on the right-hand side, bags and pillows, and then prefabricated kits and spray products. The free enterprise system has been great, and many of the manufacturers have developed products that provide suitability for use in Firestop systems that are used in healthcare facilities. But again, the physical properties of them have to serve your building's needs. Ask the questions about smoke, germ, chemical resistance, biological resistance, and make sure the product type that is used matches up with the needs of the assembly, along with the fire resistant and smoke resistant properties. Fire stopping is not usually used around fire dampers. Fire dampers are tested to UL 555 and 555S. They're installed to the manufacturer's instructions in the tested and listed systems. If you'll notice, the picture on the lower right shows metal angle around the perimeter of this fire damper. That metal angle is there for a reason. It provides the anchorage to hold that fire damper in place. The angles are anchored, as you can see, to the duct itself and not to the wall. Angles are continuous around the perimeter of the ductwork. The air handling, or the air duct, would then be attached to the sleeve, as you see here, and then the damper inside would have a heat actuator that causes the blades of the damper to close off, forming a barrier, maintaining the continuity of the fire resistance rating of this wall. If there's any fire stopping used around the penetrating item, this duct, fire damper duct, it would have been tested to UL 555S by the manufacturer, and the authority having jurisdiction would have to allow its use as well. There are some fire stop systems that are used around dampers, fire stop products, I should say, that become systems when installed to the tested and listed systems, and they would have clips installed such that they're anchored to the damper and not to the wall, and then fire stop products used around the perimeter of the damper itself. Annular space sizes would be specified in the tested and listed system, and the spacing between the angle, the clips, would also be specified. On the other side of the duct, you would find a continuous angle. So it eliminates the continuous angle on one side of the assembly. So how do we choose these tested and listed systems? That's where the difficulty comes in. There's basically 5 ratings for fire stopping. When tested to ASTM E814, UL 1479, the ratings are F, fire, flame rating, if you will. How much time does it take in minutes or hours for the fire to poke through the penetrating item to the cold side of the assembly, non-fire side of the assembly? That would be the F rating. Once fire pokes through the cold side or to the non-fire side, it would then stop the test and they would call the rating at that point. The T rating is different, the temperature rating. How much time does it take for the penetrating item to heat up 325 degrees above ambient on the cold side of the assembly, non-fire side? And that's measured in minutes as well. Metal pipes typically has a very short temperature rating because heat conducts in metal and cables from one side of the assembly, fire side, to the non-fire side very quickly. Therefore, a lot of the times the T ratings are 0. Where is a T rating required? A T rating is required when the penetrating item is outside of a wall assembly, not concealed behind a wall. Why is it needed? Fire can spread without flame ever poking through the assembly. If someone were to store boxes next to the penetrating item and it heats up 325 degrees above ambient, ambient being 75, it could conduct enough heat to catch the things that are stored next to that penetrating item, plastics and other materials, catch it on fire and spread fire without flame ever poking through. Hose stream test is required all the time. Air leakage rating we talked about, the L rating for smoke. Finally, a W rating is also a possibility for when you think you might have water that could leak from one floor to the next. So fire stop systems are specific instructions. We talked about that. The information containing the details or concerning the details are the individual systems. Key things to remember, the hourly ratings apply to the complete systems. And the products aren't assigned ratings. Only the system is, right out of the UL guide information. No substitution can take place. In other words, you can't swap out materials in that system. Have to stay with whatever is specified in that system. So very quickly, the F rating, T rating, H, L, and W are all important pieces. What's the H, the hose stream test? The hose stream test is a very difficult part of the fire stop suitability for use. The hose stream test is there to assess the robustness of the assembly. In a fire condition, the ceiling tile, which is held up by very thin steel tie wire, will be exposed to fire as the fire starts heating up. As the fire heats up and the temperature starts rising to the melt point of that thin wire, the wire gives and the ceiling then falls. It might strike the penetrating item, and when it strikes that penetrating item, it could cause a breach in the fire stop assembly. That's what the hose stream test is for. It's there to measure whether or not the fire stop system can withstand the impact that comes from things falling in a fire. All the systems are published in the FM Approvals Guide, Intertech Directory, or the UL Fire Resistance Directory. Let's take a second to talk about this the UL directory. The UL Online Certification Directory is found pretty simply. ul.com, scroll to the bottom of the page, hit the Online Certification Directory, and here we are. Easiest thing to do is go then to the fire-rated systems and products, and it brings you up to this screen. Through penetrations, joint systems, and perimeter fire containments are found in the middle of the page. The fire resistance ratings, if you had need to check out the floors, the roofs, the columns, the beams, the walls, and the fire rating thereof, you would simply click here and start looking through to find what the fire resistance ratings of those assemblies are. Fire stops are in the middle. Fire dampers, fire rate glazing is all part of this assembly. I've already selected, for instance, the CAJ 1175, and once I select that and search for it, it's going to bring up the system. And once it brings up the system, it's going to give me the F rating. So if I know the floor is a 2-hour fire resistance rated assembly, I'm going to have an F rating of 2 hours is what it's required. If that penetrating item is in a concealed space, inside a wall, not exposed to combustibles, as is required by the code, then we can use a F-rated assembly with 2 hours and note that the T rating is 0. To get a T rating, then you would look in the CAJ 5000 series. 5000 series would be the insulated metal penetrating items. And there we would be able to find T ratings that would be equal to the fire resistance rating of the floor. That's what's required in horizontal assemblies. T rating equal to the fire resistance rating of the assembly. In this case, there's a W rating of a class 1. That would provide no leaks after 72 hours of a 3-foot head of water piled on top of this fire resistance rated assembly. As you can see by the picture, this fire resistance rated assembly, for its F rating, is a penetrating item going through a concrete floor. There's a sleeve that's penetrating that concrete floor. And then number 3 would show you that there's a packing, damming, or backing material, forming material, and then some kind of a fill material, number 4. Number 1 would be the floor assembly. Number 1A would be the sleeve, and number 2 would be the penetrating item. In one of the pictures, the fire stop assembly is installed from the bottom side. When the picture shows that, and the description shows how it can be installed, then that's where we can put that fire stop assembly. Scrolling down, in this case, the fire stop is installed at the plane of the floor, not at the top of the sleeve. So then the description would tell us where that fire stop has to be installed. Scrolling down, the fire stop assembly is installed in a minimum 2.5-inch thick concrete wall or floor. It can also be used in a hollow core precast unit. Walls would be constructed of any classified concrete blocks, UL classified, so that's any thickness. Maximum diameter of the O is mentioned as 10 inches. In this case, it says the steel sleeve is optional, and it tells us what the type is. Nominal 10-inch diameter or heavier steel pipe cast into the concrete floor. So that means it can't be loose. The sleeve can be flush or project 2 inches from the top surface of the floor or both surfaces of the wall. In this case, as an alternative, a nominal 10-inch diameter sleeve fabricated from 0.019 inch or 48 millimeter thick galvanized steel, again, cast or grouted solidly into the floor or wall assembly, flush with the wall or floor surfaces. So the sleeve, the heavy sleeve, can stick up 2 inches above the floor, and the steel galvanized cannot extend past the floor or the wall. Looking at the picture, we'd never really gather that. We'd see a steel sleeve and think, okay, this can extend past the wall. But note the detail that's given in this steel sleeve section in 1A. If the assembly in the field exceeds any of these characteristics, say the sleeve stuck up 3 inches above the floor, and you were doing some inspection, due diligence inspections on the fire stop contractor, you would reject that installation. Would it mean that the contractor has to tear it out and start over again? No, it doesn't. It means that the contractor would have to choose a different system that allows that 3-inch sleeve to take place and extend past it. Here it says maximum 1 metallic pipe, annular space maximum size, 1 3/8 inch. Annular space minimum is 0 or point contact. And then it talks about the penetrating item types. Notice there's no plastic in this, only metal pipe in this application. Scrolling down further, it talks about a packing material generically, tightly packed mineral wool. That means any manufacturer's tightly packed mineral wool. And then it calls for a fire stop sealant, a 1/4 inch thick at the interface of the sleeve or the pipe of the wall where it touches point contact, and then a 1/2 inch deep, and it says flush with the top of the bottom surface of the floor or either surface of the concrete wall. So that means if the assembly was installed and you showed up and the sealant is at the top of the sleeve, that you again reject this assembly. Why? Because the installer, whether it's a contractor, your own workers from the healthcare facility, they installed it incorrectly as the tested and listed system said. So important to remember these critical characteristics as to where the product would be installed and then which product would be used. In this case, it's a 3M product. Let's take a look at a couple of the other assemblies. Here's one, CAJ 2125. The 2000 series tells me it's a plastic penetrating item. In this case, it's given me an F rating of 2 and a T rating all the way up to 3 hours. So that means that the T rating, as required by code, would be equal to the fire resistance rating of the assembly. Then it's showing me an L rating, so it tells me I can use this in a smoke barrier as well, and then a W rating. In this case, it's showing me wrap strips and collars. The wrap strips are double stacked, so there are 2 2-inch wide wrap strips, 3 of them stacked on top of each other such that there's 6 wrap strips. and then a metal collar is used around the perimeter. It's fastened to the wall or floor with steel fasteners, and then there's a band that would go around the penetrating item as well to hold that band, to hold the restricting collar together. In this case, there's one plastic pipe, either PVC, ABS, CPVC, or fiberglass reinforced pipe. Note in this case, there is no polypropylene. So if there's a polypropylene pipe, we would not be able to use it. In this case, it says 3-hour fire resistance rating based on the penetrating item. Then it's going to give us a fire stop sealant that can be used that is marked as in 3A. In this case, it's a specified technologies product with many different products used. It's going to talk about the wrap strip, in this case, 1.5 inches wide. In floor assemblies, 2 stacks of wrap strips. It's going to ask for a steel collar and tell us the gauge and thickness of the collar. It's also going to tell us how to fasten that collar to the wall or floor. Then, additionally, as an alternate to wrap strips, it could be installed as a collar kit, if you will, or fire stop device. Again, it's a specified technologies product, Spec Seal Fire Stop collar. In this assembly, it's also going to tell us that the annular space has to be a certain size, and it'd be limited to whatever it says in the system. For instance, in this case, 0 to a maximum 3/8 of an inch. So the tested and listed system is how we get the fire resistance rated assembly. Back to another design. This is an insulated penetrating item, F rating of 2, a T rating, temperature rating of 3/4 of an hour. So that would mean if it was a 1-hour fire resistance rated floor, then we would not be using the right system. In this case, it looks like a insulated penetrating item. It's got insulation of some kind. We'd have to see what kind of insulation it is. In this case, the pipe covering is glass fiber units with an all-service jacket. So looking at the insulation, we would be looking for a white-colored all-service jacket. If we showed up at the field and they used black rubber foam insulation, we'd know we've got the wrong type of insulation and ask the contractor or installer to go find another system. In this case, it's using a packing material, and it's calling for a ceramic fiber blanket or a mineral wool bat. So either or can be used. Mineral wool bat insulation is very commonly used in the fire stop industry as a packing material. Then a moldable putty, and in this case it's a 3M product. Moving on to another assembly. This is a head of wall assembly, HWD, D standing for dynamic, meaning the joint can move. The assembly ratings are 1 and 2 hour. It tells us what the joint width is, the movement capabilities, and the air leakage rating, meaning we can use these fire stop products in a smoke barrier or smoke partition. As is normal, there's a picture that describes the fire resistance rated assembly and how the fire stopping is installed. Looking at the picture, the insulation or mineral wool seems to have its fibers oriented horizontally. That's an important part to understanding how fire stopping is installed. In this case, the floor can be a fire resistance rated fluted steel deck or concrete floor assembly, and it can have fireproofing on it. Either the Isolitech Type 300 or the WR Grace MK6 or MK10B. The roof assembly, constructed as you can see here, and then a certain type of insulation on top of it, as well as fireproofing on it as well. The wall would be a fire resistance rated assembly, and it'll tell us the steel studs that can be used for the framing, and then also the type of wall board that would be used on it as well. In this case, it's telling us a gypsum board generically. We'd have to go look for the UL rating, or the UL number, which would be further up. The joint system talks about the maximum gap size, the forming material, nominal 4 pound per cubic foot, mineral wool bat insulation cut into pieces, stacked on top of each other as needed, compressed 25% in thickness, inserted into the flutes, and then it's to project beyond the side of each runner. It's compressed again to make sure that it stays in the assembly for the life of the building, such that when the gap moves, that the mineral wool moves up and down with it and remains in place. In this case, it's stating what manufacturer of mineral wool must be used in the assembly. And there are 5 of those manufacturers to choose from. Then finally, forming strips and a spray would be used over the top of the assembly. In this case, it's a Hilti product. A 16th inch dry, 1/8 inch wet, sprayed or troweled on each side of the wall or floor to completely cover the mineral wool forming material and overlap a 1/2 inch onto the gypsum board and a 1/2 inch onto the steel deck on both sides of the wall. What changes is when there are SFRM, spray apply fire resistant material applied to it, the overlap onto the gypsum board is a minimum 1/2 inch, and then onto the SFRM fireproofing a minimum of 2 inches on both sides of the wall. So again, things change when the systems change. Back to the presentation. Things that we would look for in a picture when we're on the project site. We talked about SFRMs. I'd look in the system to see if the cementitious spray fire resistant materials are allowed in the assembly, and then also what the wall is made of and what the fire stops are made of. In order to understand and analyze systems, and these are the questions that you need to know that the fire stop contractor, the professional fire stop contractor would ask, an inspection agency would ask, and you would ask to know whether or not you got what you paid for. Did the wall or floor construction type match the rating? Was it 2-inch concrete floor? Was it a gypsum wallboard assembly constructed the way it was supposed to? What's the thickness of that wall or floor? What are the penetrating items made out of? Steel, copper, plastic, what type of plastic? What kind of a pipe covering is over the top of it? Is it fiberglass? Is it Armaflex rubber? What are the annular space sizes, joint and gap sizes? And then finally, what are the backing materials and fill materials used to make that fire stop system? Finally, are the penetrating items centered or not? Are they touching or point contact? And then off we go. So what if we can't find a test and listed system in the directory? What do we do then? That's when an engineering judgment comes into play, when it's impractical or impossible and no system exists to handle the penetrating items that are shown in things like this. What's the first thing to do when we can't find a test and listed system from the manufacturer that's used in the structure? We go find another manufacturer that might have that system, because the tested and listed system wins before the engineering judgment. Why? Because the testing proves that it will pass the fire test, and that's the life safety critical nature that's needed to protect that fire resistant rated assembly. If we can't find another system from another manufacturer, then we go look for an engineering judgment or an equivalent fire resistance rated assembly. Ask for this, equivalent fire resistance rated assembly. Why? Because that puts the onus on the manufacturer to tell you that their assembly will work. Also make them say, the manufacturer, if they're giving an engineering judgment or equivalent fire resistance rated assembly, that they believe it will pass the fire test if subjected to the ASTM E814, UL 1479, UL 2079, ASTM E2307 fire test. Fire Stop Council is the manufacturer's organization that publishes guidelines about how these things are written, and again, have them say that they'll be suitable for use in that particular application. Their number one thing that they say is that the engineering judgments are not to be used in lieu of tested systems when they're available. I'm not going to read through all of these. They're on the presentation. If you want to go look at the presentation, FCIA.org for the PDF, and then watch this video again to go back to these guidelines from the International Fire Stop Council. So I've been talking for 40 minutes, and I'm just now getting to Installing Firestop products. The mineral wool is installed, as we had mentioned, with orientation of the fibers as listed in the tested system. And then the Firestop material is installed for sealants, if you will. And then all of the sealant materials require tooling or smoothing of that sealant once it's installed so that it has a uniform seal of the breach against the wall and against the penetrating item. The fire stopping is there not to treat the pipe. It's there to treat the breach between the penetrating item and the fire resistance white-rated wall, and to give that assembly its continuity back where that breach occurs. Note the safety violation. Read the safety data sheets because gloves are required. Eyeglasses would be required, as well as ventilation, as well as breathing apparatus. Again, tooling is required or smoothing. Back to the systems, though. These two look like metal pipes, and I'm guessing they're probably pretty close to using the right system with a Firestop assembly, the Firestop product going through, or treating the breach with a metal pipe going through a concrete wall. But over here, take a look at this plastic penetrating item. All of a sudden, I see this blue cable going through. A blue cable and a plastic pipe. Would mean a different system than the typical plastic pipe, which shows one plastic penetrating item going through a fire-resistance rated wall with a sealant only system. Doesn't mean that there's not a system for it. It just means that we have to find a system that shows the cable guide going through the same penetration, the same breach, if you will, where that penetration is, with the plastic penetrating items. Earlier we talked about sleeves. Take a look at these penetrating items. These are large penetrating items, probably at the lower level of a healthcare facility where the large pipes take place and are running throughout the structure. Look at those sleeves. They look thin metal to me, and it looks like there's a seam. That means it's probably a thin gauge, maybe 28 gauge sheet metal, and that the sleeve was installed after that penetrating item was installed. So again, we'd have to go back to the system and see what type of sleeve is in it. If it says in the sleeve that Schedule 10 or Schedule 40 sleeves are required that are cast or grouted into the wall, then obviously they've used the wrong sleeve and they've got to go find another system, and you reject it. But if the system said they could use 28 gauge sheet metal, and that the sheet metal can be coiled with the seam overlapping by so many inches, and that Firestop product could be used to seal the breach around where the fire-resistant rated wall had that breach, and seal to the sleeve and to the breach, then we're okay with the system. Secondly, look at where the Firestop sealant's installed at the edge of the sleeve, much further out than it was recommended in the system that we saw earlier. The system we saw earlier only allowed a 2-inch extension of the sleeve. Clearly, this is much more than 2 inches in this picture. So as we said, fire stopping looks easy, but it's actually very complex. Is it super difficult? It's not difficult as long as you understand the protocol for installing fire stops. If the annular space size is allowed to be larger than, it looks like bigger than 1 3/8, this looks like 2 to 4 inches, and it says so in the system, then we're good. We can install it that way. So fire stops are critical, whether it's a sealant system or a plastic pipe device where intumescent products are used to crush the penetrating item and form an insulating char that extends the fire rating of the wall through the assembly. Doesn't matter what product's used, it's got to be able to cover that system and make it work. The tabs of these restricting collars all have to be bent at a 90-degree angle, not 45 degrees, so that when the product intumesces, it doesn't intumess outside the assembly and simply crushes the pipe instead of expands out of it. How do you know when Firestop products haven't been installed right? Here's a good example. Look at this above the ceiling tile. Looks like a block wall of some kind. And note that the sleeves have been installed, but not much grout has been installed. Do you remember when I said in Chapter 7 of the International Building Code that calculated fire resistance could be used? Concrete, for instance, can be a way to protect certain size breaches in assembly, limited to 144 square inches for 100 square feet of wall, limited to one penetrating item, 6 inches or less, made of a metal penetrating item, and the concrete would have to be full thickness of the wall or the thickness required to maintain the fire resistance. Typically 2 to 2.5 inches worth of concrete will get you 2 hours worth of a rating. But Chapter 7 of the International Building Code is what tells us that. By putting these bags in the assembly, just like you see here, I'm not sure we get a fire resistance rating out of it. Note this one, there's nothing in it. Note the annular space around here, no grout, full thickness of the wall. People always laugh when they see this slide because it shows fire stopping around in a breach of a drop ceiling tile. But if that drop ceiling tile was part of the enlisted system, a floor ceiling assembly, maybe they would have to do something with the penetrating items. Obviously, they didn't seal the breach properly because there's a large gap right here where the ceiling tile is open. Finally, wood or wallboard compound, joint compound, gypsum wallboard compound is not a fire stop. Joint compound alone, or quote fire taping, does not provide fire resistance. A fire stop system provides fire resistance, not joint compound and some tape, and as they say, just mud and tape it or fire tape it. There is no such thing as fire tape. When looking at fire stopping, make sure to check on top of the assembly. If fire stopping isn't continuous around the whole breach, then obviously the fire stopping hasn't been done properly. Polyurethane foams that may have a UL rating for smoke or flame spread and smoke developed aren't necessarily fire stops. Be careful about these foams. Some of the packaging says that they've been tested to ASTM E814 modified and therefore can be used as a penetration fire stop. Be very careful about where you use those products. As an air seal in a non-fire resistance rated assembly, they may work fine. As a smoke seal, no, because the smoke resistant assembly is the L-rated fire stop. There in the building code, NFPA 101 or the International Building Code, there is no such thing as an ASTM E814 modified test, and therefore foam just doesn't cut it. Again, we talked about dampers. Make sure it's tested to the fire stop system as well as the UL 555, and that the damper manufacturer also approves the use of the fire stops with it. If dampers are fire stopped improperly, they could void the manufacturer's warranty of the damper, and more importantly, it might not work. Also in fire stop systems, there'd be some language inside them, inside the system, that talks about cables and penetrating items. For instance, if you'll notice, the cable penetration, or the breach, I should say, where the penetrating items go through, has a very unique situation. A steel sleeve made of thin gauge sheet metal as it passes through is there. And then it looks like fire stopping was used around the perimeter. So the system would have to allow fire stopping around the perimeter of this sleeve. Finally, it looks like a putty was used. And the cables look like they flare out as they go through the assembly. Why? Because it looks like somebody took putty and put it in between every single cable and then put the tie wire back on. That's because the system probably said, fill between interstices of the cables, or fill between every cable. When it says fill around the cables, then you don't have to cut open the cable tie and then seal around every single one of the cables. When it says fill interstices of the cables, guess what? We're filling them. Joint systems, same type of thing. A fire stop joint system is a specific construction consisting of a wall and floor assembly and the material designed to prevent the spread of fires through that. Fire stop joint systems are tested at positive pressure, and then they have certain movement classes Class 1, Class 2, and Class 3. The fire stop is tested at its maximum joint width, and then there may or may not be load-bearing characteristics. The joints can be head of wall, wall-to-wall, floor-to-wall, or perimeter fire containment assemblies, as you can see in the picture. The head of wall assemblies, when they're installed properly, have complete coverage of the fill material over the top of the mineral wool. You can almost see the mineral wool has been installed in stages. The bottom is first and it's compressed, and then this one, it looks like a plug of a mineral wool, then has complete spray over the top of it. Again, in the system, if it's going to have fireproofing on the deck, it would show fireproofing on the deck. If there's a penetrating item going through the head of wall assembly, the tested and listed system will show that. If there's no tested and listed, if the system doesn't show penetrating items, then guess what? That's another violation and a reject. Head of wall penetrations may or may not have penetrating items such as bar joists going through them. There are systems from the manufacturers that allow bar joists to go through that head of wall assembly. Make sure you use them. What's an unacceptable system? Again, wallboard compound, not good. The fire stop spray materials are not allowed to be cut with water or solvent in order to increase their spreadability and increase the flowability of the product through the pumping equipment. The mineral wool has to be installed uniformly in order for that spray to get continuous fire resistance rated assembly to work. Uniform thickness, you heard and saw 16th inch wet, 8th inch wet, 16th inch dry. Perimeter fire containment systems in new construction, again, specific field-directed construction, a non-rated curtain wall assembly to a fire resistance rated floor assembly. Whole idea is to extend the fire resistance rating of the floor to the outside of the building. What they do to test it is set up a fire test facility that produces an exterior fire attack and an interior fire attack to protect the spread of fire through the safing slot. And again, the orientation of the mineral wool is got to be correct. In this case, it's compressed, dropped into the opening, and then allowed to open such that when the wall and floor move, it provides compression so it'll stay in place. A spray or a sealant would be put over the top of it to provide fire resistance. Now, what about the I&M? We talked about the products and tested listed systems. And although I didn't talk about heavily the installation, you know, the products and touching it with your hands, and do you use a caulk gun, and what kind of caulk gun, and how much do you tool it, and all that kind of stuff, it was very evident that the system selection is really the key to making this work. What you don't want to see is the Cirque du Soleil of fire stopping. Spray paint. 1, 2, 3, 4, 5 people. No safety equipment. No ladders. Fire stop systems have to be installed to the tested and listed systems. If it's done wrong, there's a life safety risk. There's 3 methods to install it. Either he or she who pokes the hole fills it, or there's a specialty fire stop contractor, single source, that installs it. FCIA member in good standing, or FM and UL contractors. The ratings are complex. The FT, H, L, and W we talked about. And the documentation is critical for you to have a program to manage after you've got the building. Fire stop products are sold all kinds of different ways. Hardware store, specialty distribution. The manufacturers have done a lot to try to educate everybody that installs fire stopping. They've got 1-hour programs, half-day programs, 2-day programs at their warehouses, their headquarters. They've done a lot to educate. However, there's more. A UL qualified or FM 4991 approved company is available. How do you select a contractor to install these things? Ask these questions. Are they an FCIA member? ASHI members provide great services to the buildings that they work in. FCIA members do the same thing. They've committed to membership, committed to working on committees, committed to making their industry better. Do they have a workforce that's educated as a fire stop containment worker? The FCIA has a 1,000-page book, 22 education PowerPoint presentations, 22 outlines, 22 quizzes, and 2.5 to 4 hours worth of video available for training of the workforce. The contractors should be training their people as fire stop containment workers. Do they have references? And are they FM approved or UL qualified? What is this FM approval or UL qualification? It's a management system audit. It's where FM or UL comes out to the office and does a facility audit, facility procedures audit of the contractor company. Do they have the procedures in place to select the fire stop systems, communicate them to the field, and then make sure they're documented and wind up in your hands and also kept in their offices for 7 years? Then FM or UL goes to a job site and does an audit to be sure that the contractor does as they say they do by checking the systems. In order for the company to become an approved or qualified contractor, somebody has to take an exam administered by FM or UL and pass it 80% or better. And then they get an annual audit. The FCIA could have done their own accreditation program, but we felt it brought more credibility to have a third-party audit done by UL or FM, a third-party objective organization that provides assurances that the companies have qualifications that are quantifiable. So their management system gets written and it gets audited. Look at this outline. Does it look familiar? It should, because it's similar to what you do for your policies and procedures all day long, and then get audited by the Joint Commission and others about how your management system works. This is how the contractors or the contractors get audited to this management system. So look for a company that has the FM approved contractor label, the UL qualified contractor label. They have to invest in their company, invest in their individuals, and provide you with great services to wind up being FM or UL. Inspection is something that takes place as well in new construction especially. ASTM E2174-2393 are 2 inspection standards that were developed at ASTM with the manufacturers and contractors working together with the consultants to provide an inspection process that's uniform. How do you cut the fire stopping? Where do you measure it? Currently, you measure it at the bond line where the fire stop material touches the wall or the floor. In other words, the breach connects with the wall or floor as well as the penetrating item. 3 types of inspection. All UL and FM contractors do some kind of inspection of their own work. They verify that their management system works. Manufacturers don't inspect. They recommend third-party independent inspection. And then finally, the ASTM E2174-2393 independent third-party inspections are done at a specified frequency. They're specified as mandatory by the 2012 International Building Code for buildings 75 feet and higher above fire department access, lowest fire department access, and occupancy pipe type 3 and 4 in table 1604.5. In NFPA 101, you'll find them in Chapter 8 in the Annex. It's a standard practice for the on-site inspection of installed fire stops that protect the breaches that are made by penetrations and joints. It's a standard inspection procedure done by independent inspection agency companies. The companies have to be independent of and divested from the installing company, meaning they're independent of the distributor, manufacturer, a competitor of the contractor installing, and the supplier. They can't be a competitor, and they have to submit notarized statements thereof. The inspector personnel have to have at least 2 years' experience, be accredited, and meet ASTM E699. There's an IAS AC291 accreditation program, similar to the FM and UL Fire Stop contractor program, but this AC291 is meant for inspection agencies. An individual inside the company has to pass an exam, and then they have to get themselves audited just like the contractor would get audited to their management system that would be similar to the contractor management system. Employee training, communication of systems, how they check the systems, how they inspect the ASTM E2174-2393. Pre-construction meetings take place, documents are reviewed, manufacturers' product data sheets, tested systems and safety data sheets, mock-ups are built and destructive testing takes place, and then During construction, 10% random witness, no less than one per each, one of each type for 10,000 square feet of floor area, no less than 5% of total lineal footage of joint as well. Then there's a minimum of 2%, no less than one of each type per 10,000 square feet of floor area, and a minimum of one for every 500 lineal feet of joint area. If there's 10% variance, the inspection stops, then they come back, inspect it, do it again. Reports are done, given to you, the building owner and manager, because you're the company that hires these special inspectors who work for special inspection agencies. Documentation is critical, though. You've got to get the documentation, the tested and listed systems, in order for you to manage the barriers effectively as they were installed in the first place. On to the DIIM, the M for maintenance and management. First, a specification. I talked about 078400. I'm not going to get into the details here. Visit FCIA.org. Check out our specification. It's free. But there's things that you need to have in Part 1, 2, and 3 of the specification. The standards need to be listed. And can you have a single product that's specialized? Yes, you can, and EJs, engineering judgments. You really want to have tested and listed systems. That means you might have more than one product in stock for your maintenance along the way. What about that maintenance and management? What's required? Currently, there's no requirement to have labels on your walls of every one of the fire stops that protect the breaches in those fire resistance rated assemblies. The only thing that's required is this sign on the lower right. It says that you have to identify the barrier. That barrier has to be identified and marked on the wall itself. The International Building Code has specific language in Chapter 7 in Section 703. And in the future, the International or the NFPA 101 will have that as well. How do you keep track of all these penetrating items, the fire doors, the fire dampers? Well, there's three methods, either with a paper system, a file cabinet with all the systems in it, a software program or an app of some kind, and most importantly, labeling. If it's specified early on in the construction, then you'll know how to maintain. Why? Because if the label doesn't have the UL number, Intertech number, or FM approvals number on the wall itself, you don't know what system was used, nor would you know what products to use to maintain the fire stopping that's in that wall or floor. The fire codes call for maintenance. In Section 4.5.8 of NFPA 101, the 2012 version, the 2000 version doesn't look much different. It talks about continuous maintenance of the fire resistance rated assembly, and that the continuity's got to be maintained. It also has even more about the continuous maintenance, even such that it's got to be performed under the supervision of a responsible person who ensures that the testing is done at specified intervals. The International Fire Code goes on to say that the fire resistance rated construction and smoke barriers, etc., shall be maintained. They also shall be visually inspected by the owner annually and properly repaired, restored, or replaced where damaged, altered, breached, or penetrated. And then records of the inspections and repairs shall be maintained. That's some pretty strong language in both of these codes. Look at this in the fire code of the NFPA 101. It doesn't say that you have to do this once a year. It says that the inspection and maintenance has to be done at specified intervals. The fire code, though, says once a year. So you can bet that a court of law will look and say, okay, the due diligence says that they have to be looked at least once a year. These are in the fire codes, NFPA 101 and the International Fire Code. Then it goes on to say that the openings made for passage of pipes, etc., shall be protected with approved methods. Approved is a defined term. Approved means approved by the building code official. And then also meet the fire resistance rating of the assembly itself. Then it goes on to talk about smoke barriers and smoke partitions, fire barriers, fire walls, and fire rooms as well. Go to Canada, same thing exists. Fire separations have to be maintained. Go to the United Arab Emirates, looks like the same language that came right out of the International Fire Code. So what's a facility director, a facility engineer to do? Remember, barrier management begins when new construction ends. Keep an eye on things. When somebody wants to go up on the 3rd floor of your building and say that they want to run a pipe through that assembly where the circle is, maybe bring it up from 342, have that penetrating item penetrate the red here, which might be a 2-hour fire-rated assembly, and then go through a smoke barrier here, would be a minimum of 1 hour fire resistance rated assembly with the air leakage rated fire stop, and then service room 308. You have to manage that somehow. How does it get maintained? The wall or floor, the doors, the dampers, the joint systems, the laboratory waste systems, all the med gas piping has to be taken care of as these penetrating items are going through the wall and the floor. And the fire stop system would be used to document the penetrating items as they go through your walls, floors, with all kinds of different penetrating items, whether the cable trays, med gas, laboratory waste, BX cables. There's all kinds of things that penetrate that fire resistance rated assembly. So when you think about it, above that fire door that I showed you earlier, the wall itself could look like this, and there would be a fire stop system that would match up to every single one of those assemblies. How do you manage it? Some kind of a barrier management policy. That policy's got to be in your culture of your company, in the culture of your organization. There's got to be rules for those people that are going to penetrate barriers for internal contractors and external contractors. Your own IT department, your own repair crews, your own service crews, and then those external contractors. Your policy could be that when a worker comes to a barrier, they breach it, put their penetrating item through it, notify your office of the breach. A separate crew would then go up and install the fire stopping around that. Or if you have that penetrating item and the breach protected with the fire stop system installed by that contractor, make sure the systems are correct that have been installed and that they've got them labeled afterwards. Barrier warnings are required by the International Building Code, going back to the 2012 version where it says 1 hour, 2 hour, 3 hour fire barrier, protect all openings, all that kind of thing. Whatever it is, your barrier management policy has to have rules of engagement, meetings for pre-construction, permissions, maybe a sticker that goes on the ladder that allows them to be above ceiling, an above ceiling permit, and then a barrier permit to go with it. There's got to be consequences to the violations. If they don't have a permit to work above the ceiling and violate barriers, then their warning is 2 strikes and then you're out on the 3rd, or 1 strike and you're out on the 1st. Whatever it is, your policy has to state it and be managed and then enforced by the staff that is closest to the barriers that are being penetrated. So we spent some time together on the design, installation, inspection, and management of fire stopping. I hope that during our program you learned a couple of key things. The first one is that a system is what makes a fire stop. It's what makes a fire-rated door. It makes what makes the barrier itself. It makes the damper. They're all tested and listed systems. They've gone through a fire test. They've gone through a hose stream test for robustness to simulate things falling in a fire and impact. If it's a damper, it went through a drop test. If it's a door, it might have gone through an impact test and a positive pressure test. If it's a fire stop and a smoke barrier, it went through a air leakage rating test to measure air as it moves through the assembly, simulating smoke to protect against smoke moving from place to place. So we hope it's designed properly, a test and listed system, installed by companies that understand and respect the system. And so therefore your question to the contractors are simply, what system did you use to make that door, fire stop, damper, return the wall or floor to the fire rating it was before somebody poked a hole through it? Then inspection for new construction by inspection agencies who are accredited. Finally, maintenance with a barrier management system of some kind. So I hope you have enjoyed our short program on fire stopping, our short dissertation on barrier management. We've enjoyed spending some time talking to you about our industry and how it works. You may be wondering why there were so many picture or non-picture slides and so many system slides. Because it's the systems that set up the ratings, it's not the products. We invite you to subscribe to Life Safety Digest, the magazine of effective compartmentation, to learn more. The magazine is archived at FCIA.org. Specifications and all kinds of other resources are also available at FCIA.org. The Barrier Management Symposiums are advertised at FCIA.org. They're also found at the ASHI website as well. Watch your regions for barrier management symposiums that are coming to you. They're full 1.5 day programs where we cover every bit of the details for each fire resistance rated construction discipline. They're great programs, and will teach you how to manage your barriers, how to instruct the specifier to make sure that in new construction or additions you get the building delivered the way you want it so you can manage it and maintain it afterwards as well. So on behalf of the Firestop Contractors International Association, I'm Bill McHugh, Executive Director of the Firestop Contractors International Association. Feel free to call me if you have questions at 708-202-1108 or email me at bill@fcia.org. Thank you again to the ASHI membership, to the advocacy organization for inviting us to provide this presentation as a resource for you to use to meet the requirements of A, fire and life safety, and B, keep our patients and staff and visitors safe at the end of the day, because that's our objective, a safe building for all, especially the patients that can't defend themselves. Thank you, everyone, and have a great day.